Hi, eighth graders. We are now going to look at weak relationships or weak correlation coefficients and what graphs would look like there. So in the last video, we looked at strong correlation coefficients. Let's see if I can do this again. Strong correlation coefficients, and we came across things like this. There's this one, which is a very strong 1.0. We could also say there's this one over here that we could say is probably a really strong 0.9. Those are great those are great for us to see that sort of very clear linear relationship that is existing there. These next two graphs that we see here, these are examples of weaker relationships. These two graphs up here, we could make very confident predictions about what we could potentially see in our data. This one in particular, we could be very, very confident with saying, probably within a couple of numbers, what some data would look like if we were predicting numbers that were up high or down low with this data. If we are looking at this data, we could be pretty certain that we're going to pick a data point. If we're filling in this gap right here, we could pick a data point that probably would fill in that nicely and be reflective of real life situations. These next two graphs that we see here, they clearly have positive relationships, one more so than another. This one, for example, has a clear positive relationship. This one's a little less obvious, but they are even more scattered. They're so scattered that I would have a very hard time feeling very confident with predicting something beyond this x value. If I were to say, what would 20 represent in terms of y values? I would potentially have a number span that's in the 20s to 30s for that particular data point, and that makes me very nervous. I'm not going to be very confident in that. This one, however, I'm looking at a span of data that's maybe in the 15 to 20 range, so I feel a smidge more confident, but again, it's still very, very, very scattered to a point where I wouldn't feel that confident in my prediction. So for example, I could draw a line through this data, but if I were to look at the reach of the data that's there, I am looking from, it looks like 15 down to 4. So like the span of this data is 19 or 20 units around each and every point on this line, which is huge. That is enormous. So if I were to put all of these data points into a calculator and actually calculate the official correlation coefficient given the line of best fit that the calculator could also provide me, I'd probably get a correlation coefficient that looks something like this. 0.4 or 0.3. It'd be really low, and really low being that if the closer it gets to 0, which is no correlation, I'm sure it probably needs to have one more L in it. Nah, correlation, that looks good. All right, so no correlation. Zeros are no correlation. That means 0.4 is getting pretty close to 0 when this is the strongest relationship I can have. A 1 is my strongest relationship. 0 is my least strong relationship. That means this graph of saying this is a positive 0.4 is showing that it's 1 going positive, but 2, it's not a very strong relationship. Now, it clearly has some relationship because I could make a general prediction, but it's not going to be very accurate. If I look at this next graph over here, I have a much different situation than all of these graphs so far. If I look at this graph, I could maybe draw a line of best fit, but in all reality, it's a possibility that my line of best fit might look best like this, being almost horizontal versus just even sort of positive. Because I have so much variation in that line of best fit and what could be ideal for it, and I would have to put it into a calculator to even figure that out, I really can't with much confidence say that I know what the correlation coefficient is. I think this is a prime example of a 0.1 correlation. There might be some rhyme or reason to the points, but it's so little that it truly is so close to zero that it doesn't even matter for us to say that there's a relationship here. The relationship is so weak that we can't even accurately draw a line of best fit or even predict where the data is going to go for future numbers. So, for example, we have strong correlation coefficient from the last video, a fairly strong correlation coefficient here. We're getting weaker to almost completely non-existent when it comes to correlation. So we would say strong for these top two graphs from the last video and weak for these next two graphs here. We're going to watch one more video to look at the sort of continuum of correlation coefficients. And this continuum is going to span from -1, so incredibly strong negative relationships, all the way up to 0, and then passing that and going to positive ones, so we can look at those incredibly strong positive relationships. Once you've watched that next video, you'll be free to complete the must-do problems and the exit pass for this lesson. Thanks for listening. Thanks for watching. Bye.